The modern car is an incredibly complex machine with lots of electronics to make it work. It's even considered by some to be a computer on wheels thanks to how many computers are inside of it. But before any of this existed, cars were much simpler machines that only had an engine, a transmission, and a steering wheel. So here are 4 technologies that turned cars into computers. Starting off in 4th, we have ignition. You might not think that ignition has anything to do with turning your car into a computer. But before electronic ignition, cars would actually require you to hand crank them in order to start the engine. This meant that when you turned your key in the ignition, it was actually a physical switch that would connect your battery to your starter motor, which would then turn your engine over and over until the engine was able to catch a spark from the spark plugs and ignite the fuel. The first electronic ignition for a car was created by Charles Kettering, who, after several attempts, was finally able to get a working model in 1916. His system consisted of a battery, a distributor, spark plugs, high-tension wires, and an ignition switch, all of which are still used in modern vehicles today, just now controlled electronically. The original design used mechanical contacts to break and make a circuit for the spark plugs. But these often resulted in the plugs being damaged or not firing at all. In order to improve this, solid-state components were used that could better control the flow of electricity to the plugs. After its invention, almost every single car started to use electric ignition, since it made starting your car a lot easier than having to hand crank it. And it also helped increase the reliability and performance of the vehicles. Moving up to 3rd, we have the microprocessor. Without microprocessors, cars wouldn't be able to function like they do today. A lot of critical functions in a vehicle now rely on these small chips, which can process information extremely quickly and accurately. There are hundreds of microcontrollers and processors in modern vehicles that help control everything from the power, steering to the traction control and anti-lock braking systems. These processors also work together to collect data from various sensors around the vehicle, allowing them to make decisions about how to best operate. Before microprocessors, most of these tasks would have been handled by a person driving the car. But now they can be done by a machine that doesn't get tired or distracted. Microprocessors have improved safety and handling of the vehicle, while also increasing efficiency and performance. They've allowed for features like cruise control, automatic transmissions, and lane departure warnings, which makes driving less tedious and potentially less dangerous. The first microprocessor used in a car was the Intel 8008, which was used in the 1972 Datsun 260Z. Since then, newer and more powerful processors have been developed specifically for automotive applications, such as the Tri-Core and the Renesas RX series. These chips are typically more robust and reliable than general-purpose processors and are designed to withstand the harsh environment of a vehicle. As cars continue to become more computerized, it's likely that even more sophisticated processors will be developed to meet their needs. Moving up to 2nd, we have the CAN bus. One of the main reasons that cars have so many computers is because there are so many different systems that need to be monitored and controlled. A car has a lot of moving parts, and it takes a lot of coordination to keep them all working together properly. The CAN bus is a communication protocol that allows different computers in a car to communicate with each other. This allows the different computers to share information and coordinate their activities, which is essential for a car to run smoothly. For the CAN bus, each computer in a car operated independently, and there was no way for them to share information. This led to a lot of wasted effort and potential problems. For example, 2 computers might try to control the same component at the same time, or one computer might send a signal that it's not supposed to. The Controller Area Network, or CAN, was developed by Bosch in the early 1980s and quickly became popular in the automotive industry. It's a serial communication protocol that uses a common bus to connect multiple devices. Each device on the bus has a unique identifier, which allows the CAN bus to handle a large number of devices. The CAN bus is also very robust and can handle a lot of noise, making it ideal for use in cars where electrical interference is common. Thanks to the CAN bus, cars are able to function safely and efficiently. The different computers can communicate with each other and coordinate their activities, which reduces wasted effort and potential problems. As cars become more computerized, the CAN bus is likely to become even more important. And in first place, we have the OBC, or the Onboard Diagnostics Computer. At the beginning of the 1980s, vehicles began to become more complex, which made them more difficult to repair. Consumers felt that they were becoming too dependent on mechanics and wanted to be able to diagnose and fix their own cars. As a result, the US government passed a law requiring all vehicles to have an onboard diagnostic system. This system would allow mechanics to connect a computer to the car's diagnostic port, which is usually located under the dashboard. The OBD computer would then test the various systems on the car and provide information about any problems that were found. This made it possible for consumers to diagnose and repair their own cars, which saved them money on labor costs. It also gave mechanics access to a wealth of information about the car's systems, which made it easier for them to diagnose and repair problems. Since its introduction, the OBD has become a standard feature on all vehicles sold in the United States. Other countries have followed suit, and now the OBD is a common feature on cars around the world. This has allowed consumers to take more control over the maintenance and repair of their own vehicles. The OBD has also made it easier for mechanics to diagnose and repair problems, which has improved the overall quality and safety of vehicles. Today, the OBD is an integral part of most vehicles, and it plays an important role in ensuring that they run smoothly and safely. Thank you guys for watching, and see you in the next video. If you enjoyed this video, please hit the like button and subscribe for more videos about technology and coding. Also check out my new channel where I share some of my coding journey.